All right, hi folks, this is Larry Mussolino. I wanted to record a short video here for the Module 2 skills practice and help you get started with the typical question that you'll come across in this homework. So let me come here. This is homework problem 1. And so here's what it says. It says find the slope of a tangent line to the curve at a certain point. So what is that really asking you to do? Well, if you think about this graph, I'm just going to draw a graph. Let's draw it like this. All right, so this is the graph of y equals 3x squared plus 3x. It might not be the exact graph. I'm just coming up with a general sketch. All right, let me come to this point, negative 2.5, 11.25. I'll show that in red. That's going to be somewhere up here, let's say. So here's the point. Well, the tangent line is a straight line that touches the graph at that curve. Okay? And you could see that this is going to be the answer for the graphing part of it, because a tangent line has to touch the graph at one point like this. This can't be the answer here. This graph is wrong, because a tangent line is just touching the graph at one point. This is actually going through the graph at two lines. This is actually called a secant line here, but it's not the tangent line. Again, this is going to be wrong, because the red line would have to touch the blue graph at one point shown in graph D. So I know that's going to be the right answer. All right. So what they're asking us to do is find the slope of that red line. And that's what we're going to need to do here. All right. But before we do that, let's go to the table they want us to fill in. For the table, they say find the slope of the secant line. And they're going to ask us to notice what's happening with these slopes. So here's what we're going to do. Let's get started. So they want us to find the slope when the x value here is -2. All right, well, -2 is maybe like right here. I'm going to draw this graph a little differently. Let me start over again. So let me draw this graph kind of like this, let's say. I just want to emphasize. So here's -2.5, let's say. And here is, let's say, -2. Now, when they say a secant line, what they mean is a straight line joining these 2 points. I'm going to draw a straight line joining those 2 points. This line is called a secant line. Notice this is not a tangent line. A tangent line only touches the graph at one point. So what they're asking us is find the slope of this blue line. Well, to find the slope of a straight line, you use y2 minus y1 over x2 minus x1. You probably remember this from algebra. All right, so let's do it. So the first point is going to be -2, comma, question mark. What is the y value when x is -2? I got to figure that out. Well, here's the equation that gives me the y value for any x. So let me work it out down here. Y is 3x squared plus 3x. Well, we want to know the y value when x is -2. So I'm going to plug in a -2 here. All right, let me work this out. -2 squared is 4. 4 times 3 is 12, so that's going to be a 12. 3 times -2 is a -6. 12 plus -6 is a +6. So this y value here is 6. So this point right here is -2, comma 6. All right, the other point we want is given to us. This point here is -2.5, 11.5. 11.25. All right, let me label these points as x1, y1, x2, y2. So now I'm just going to go and plug in the slope formula. y2 is 6. I'm sorry, y2 is 11.25. y1 is, I'm sorry, I labeled this. This should be y1 there, my mistake. Let me start over again here. So let's drop into the slope formula. We need y sub 2. That's a 6. Y sub 1 is 11.25. X sub 2 is negative 2. X sub 1 is negative 2.5. And if you work this out on a calculator or by hand, you get negative 10.5. So that's this answer here, negative 10.5. So the slope of this secant line is negative 10.5. It makes sense. I could see the secant line is going downhill, so it should have a negative slope. All right, well, I'm going to do the same procedure to fill in the slope for Q2. Q2 is, I'm going to redraw the graph here. Let me get rid of this graph for a second. And I want to show you Q2. Q2 is taking a point that's a little closer to the point P. So here is our graph. And here is point P, right, at negative 2.5. Now Q2 says go to negative 2.4. Well, negative 2.4 is very close. Now I'm going to be finding the slope of this blue line, this secant line here. And if you work that out the same way using the slope formula, you'll come up with negative 11.7. What if you make the point even closer to P? I'm going to use negative 2.49. Of course, that's going to move the point here. Well, the slope is negative 11.97. What if you move the point Q even closer, negative 2.499? I could see the slope is negative 11.997. And to find the slope of the tangent line, these points, Q1, Q2, Q3, Q4, are getting closer and closer to P. And as that happens, these secant lines, because remember, the secant lines would be doing something like this. So this would be line Q1, Q2, Q3. Well, these secant lines are getting closer and closer to the actual tangent line. So I'm noticing what's happening to these slopes. They're getting very close to negative 12. That's the answer to the slope of the tangent line. Now, there's actually a formula that you can use to find this slope. And let me do an example with that. But for this example, we were able to see how the slopes of the secant lines were getting closer and closer to a value. The value here turned out to be negative 12. All right, let me go do another example that's very typical. All right, folks, let me do another typical example. Now, remember what we're trying to find here is the slope of what's called a tangent line. So let me just draw a typical tangent line. So let's say I want to come here to, I'm going to call this T. Let's do T equals 5, let's say. Well, the tangent line would look something like this. And I want to know what is the slope of the line. I'm just going to make something up. I'm going to say the slope is 7. We call this the instantaneous velocity. So in this example, the instantaneous velocity would be 7. Now, there's another measurement called the average velocity. The average velocity is the slope of the secant line joining 2 points. So let's say they said, what's the average velocity between t equals 1 and t equals 5? Well, to answer that, I would come here to the curve at t equal 1. Let me draw it down here, t equal 1. And I would visualize a secant line going through this curve. The slope of the secant line, let me make something up here. I'm going to say the slope is 3, just to make up a number. That slope 3 is the slope of the blue line. That's the slope of a secant line. That would be called average velocity. And for average velocity, you need 2 points, because for this, you're going to be finding the slope using the slope formula from algebra. But what about instantaneous velocity? Well, instantaneous velocity is the slope of the tangent line. right? In this case, I use the example 7. All right, so how do you find the expression for the instantaneous velocity for any time t? Well, it's a kind of a messy formula. Let me show it to you. What you do is to find the slope of the tangent line, let me write slope of tangent line. It's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. All right, I'm going to plug into this formula in a second. Let me go off to the side here, and let me just work out f of x plus h. All right, I'm going to write this as f of t to make it a little easier to see. They gave us f of t, 3t squared minus 4t. All right, let's do f of x first. That'll be a little easier. Well, f of x is just going to be 3x squared minus 4x. I'm just going to this function here and replacing t with the letter x. All right, let me do f of x plus h. What that means is take this input, x plus h, and anywhere you see a t, replace it with this expression, x plus h. All right, let me work this out. This is going to be a little bit of messy algebra. X plus h squared, I have to think of that as x plus h times x plus h. All right, I'm going to do this multiplication. This is like a FOIL kind of multiplication. If you multiply that out, you're going to get x squared plus 2xh plus h squared. All right, let me keep going. I'm going to multiply the 3 inside the parentheses, so it's going to be 3x squared plus 6xh plus 3h squared minus 4x minus 4h. All right, I'm ready to go back and plug into this limit. Let's do it. So it's the limit as h approaches 0. And by the way, this limit as h approaches 0, what that's simulating are those points getting closer and closer. Remember Q1, Q2, Q3, Q4? Those points get closer and closer to that point P. Well, h is the horizontal distance between those 2 points. So what we're simulating in this limit is those points getting close, the Q points getting closer and closer to the P points. All right, anyway, let me plug in this f of x plus h here. So it's going to be 3x squared plus 6xh plus 3h squared minus 4x minus 4h. All right, now I got to subtract the f of x part. Well, the f of x part was down here. So I'm going to subtract it. So it's going to be minus 3x squared minus 4x. I got to be careful because I'm putting this in parentheses, because this is going to end up being minus 3x squared plus 4x, right, when I distribute this negative sign in the parentheses. And this is all over h. All right, well, I'm noticing there's a little bit of canceling that can be done here. Because here's a plus 3x squared and a minus 3x squared. So I'm going to wipe those out. Here's a minus 4x and a plus 4x. I'm going to wipe those out. All right, here's what we have left then. 6xh plus 3h squared minus 4h all over h. All right, here's the little trick now. I want to cancel out this h in the denominator. So what I do is I factor out an h from the top, because here's an h, and here's an h. So let me factor that out. If I take the h out in front, it's going to be 6x plus 3h minus 4 all over h. Well, now I can let the h's get canceled out. This h cancels out with h. So I'm almost done. I have the limit as h goes to 0 now of 6x plus 3h minus 4. Now I'm going to take the limit. That means I'm going to let h go to 0. Well, if h goes to 0, this 3h goes to 0. And that leaves me just the answer 6x minus 4. So this is, we call this the derivative function. We label it as f prime. What this does is it gives you the slope of the tangent line for any value of t. And I'm going to use this 6t minus 4 because in our example, we use the letter t. All right. Now that we have that done, it says, what's the instantaneous velocity at 2 seconds? Well, to find that, instantaneous velocity is the slope of the tangent line. And to work that out, I'm just going to go to the derivative function and plug in the number 2. So that's going to be 6 times 2 minus 4, which is 12 minus 4, which is 8. So that's this answer here, 8. What it's telling me is the slope of that tangent line at t equals 2. Let me draw it here. So I'm going to go here to t equal 2. And I'm going to draw a tangent line. The slope of this blue tangent line is 8. That's what we just figured out. Okay, folks, so remember, if they ask you about average velocity, that's going to be a slope formula from algebra. That's going to be the y2 minus y1 over x2 minus x1. That's really the slope of a secant line. If they ask you about instantaneous velocity, that's this derivative function. And you've got to go through this messy limit process for that. All right, folks, hope this is helpful. Folks, please remember to use the view an example buttons and help me solve this buttons if you get stuck. All right, folks, hope this is helpful as you're working in Module 2.